One of the most exciting developments for Moodle in terms of accessibility is its new feature of supporting accessible math. This was introduced alongside the Addo equation editor. The way that math content is handled in Moodle is equations can be created using the equation editor provided within Addo. You can do that either as a WYSIWYG editor, where users can build and construct their own equations from scratch just by clicking and dragging on the various controls to build an equation, or if you're a user of LaTeX, if you're familiar with writing equations in tech, you can actually copy and paste those into the Addo equation editor, and those will be displayed. The way that equations are displayed within Moodle is the equations are rendered and displayed using MathJax. This provides a lot of very useful features and a lot of accessibility enhancements. One of the big features that it provides is that it makes equations look consistent, whether you're using Firefox or Chrome, Internet Explorer, or Safari. Those equations should really look the same across the board because it's MathJax that is generating that equation and not necessarily the web browser's MathML support. In terms of accessibility, it's very useful. MathJax actually provides the ability to zoom in and magnify equations rather than displaying them as a PNG image, which could pixelate. MathJax actually provides that zoom functionality within MathJax itself, so you can zoom in on equations without them pixelating. For screen reader users, MathJax is really great because it provides support for interacting with that equation with speech, or if your particular screen reader supports it, using Braille. This will work in Firefox or Internet Explorer using JAWS or NVDA, non-visual desktop access, with the free Math Player plugin. So I'm going to go ahead and demonstrate this real quick.
Moodle colon best practice. Math heading level here. Math heading level Addo equation at sample equations heading level 4 clickable.
So here's a heading where we have some sample equations.
Pythagorean theorem heading level 5 clickable.
So the first equation is the Pythagorean theorem.
Blank.
And let's hear how it reads.
A squared plus b squared equals c squared. Math content clickable.
A squared plus b squared equals c squared, math content. That last bit where it actually announced that it was math content is an important thing to note. That's the screen reader's way of letting you know this has been recognized as math content. And so you have the ability to use any special math functionality provided by your screen reader.
Quadratic formula heading level 5
The next heading here we see is quadratic formula, so we'll play that equation.
Blank. X equals fraction, negative b plus or minus the square root of b squared minus 4c, over 2a. Math content clickable.
So same thing. At the end of the equation, it reads out math content clickable.
Enter.
So one of the features that JAWS provides for math content is what they call the math viewer. The math viewer will display the equation visually up on screen, but it also allows the JAWS user to more precisely navigate that equation.
Math viewer,
rather than reading it out as one large chunk, as it did just a moment ago. Within the math viewer, you can actually navigate it piece by piece. So my math viewer has loaded, and now I can use the left and right arrow keys to move through the equation.
Equals X equals negative b plus or minus the square root of b squared minus 4c, over 2a.
Now if I wanted to zoom in on a particular portion of the equation, I can do that as well.
Negative b plus or minus the negative b, plus minus sign, square root of b squared minus 4c. b squared, minus 4c. No more terms at this level of the current expression.
And with JAWS, this would also be displayed in Braille now on an external Braille display.
Escape, course colon, mass-energy.
And the last one I'll show you here is a very simple one.
Blank. E equals mc squared. Math content clickable.
E equals mc squared math content. So again, I could open up the math viewer here if I wanted to. Prior to Addo and its use of MathJax, had I have tried to create this equation, I could get it close. But with this example, the exponent is what would cause the problem. So prior to Addo and MathJax, that equation would actually be read out as E equals MC2. It would not correctly have announced the fact that that 2 is actually an exponent. It's to the second power. And so now with Addo and with MathJax, those equations are accessible in both speech and in Braille.